In this activity, we'll be creating a program that utilizes trait objects. Once you're ready, load up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your Activities directory. We are on Activity 31, so scroll down to A31 and open it up. Once your activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. This activity topic is trait objects. We have a summary here to give an overview of what we'll be making. And it states that a contractor wants a program that can sum the cost of materials based on how many square meters are required for a job. So it's just going to be a basic utility that's essentially a calculator. Our program requirements are to calculate multiple material types with different costs. So each one needs a different cost. We must be able to process a list of varying materials. That's where the trait objects will come in. We then have material types and cost lists. So we have carpet, tile, and wood, along with their respective costs. And we must make sure to take square meters into account when we're calculating the price. We have some notes. We should create a trait that can be used to retrieve the cost of a material. We can create trait objects and store them in a vector for processing. We should use a function to calculate the total cost. And we need to process at least 3 different materials. The first thing I'm going to do is create a trait to process these materials. So I'm going to call my trait material. And it's going to need 3 functions. So we'll have the cost per square meter. So this will be defined on each structure and how much it costs just to purchase 1 square meter. We'll then have the number of square meters. Square meters will return the total square meters of the material that we require. And then finally, we'll have total cost. And we're going to provide a default implementation by using curly braces here at the ends instead of using a semicolon. So when we have a semicolon, that means that the implementer must implement the functions. But if we provide the curly braces, we can implement a default function that all of the implementers can use. We can override this if we'd like, but for the most part, we're only going to need the default. So it's going to take the cost per square meter, and it's going to multiply that by the number of square meters that we have for this particular material. And that should give us the total cost for that material. You might have noticed that we created these 2 functions specifically to use them in our total cost function. The reason we did that is because traits can only access data through functions that are implemented on a structure. Traits are unable to access any fields in a structure because each structure might have a different field. So we have to rely completely on functions to get any values. Next, I'll create these structures for the different material types. So we'll have a structure for carpet, and it's going to have an F64. This F64 will be the total square meters that we're working with. I'm also going to do tile, and I'm going to do wood. The next thing I'll write is the function to calculate the total cost. So I'll just name it total cost. And it's going to have a listing of materials, which is just borrowing a vector. It's going to take a box din material. And it's just going to return an F64. And to calculate the cost, we're going to use the material.iter function to get an iterator. We're then going to map the material. And we're going to access the total cost function to get the total cost for this specific material. And then we're going to sum up each one, and that should give us a total cost. With this function, we're working with a vector of materials, so it can be any structure that implements that trait. We can put different types of structures within this vector because we're boxing this data, and a box always has the usize type. So usize is always the same, so it's no problem to put it into a vector. Remember, we have to have the din keyword to let Rust know that we're working with dynamic dispatch. The next thing we should do is implement the material trait for our structures. So we'll implement material for carpet first. And we'll need to implement the cost per square meter. And the cost per square meter for the carpets is listed up here at $10 per square meter. So this is just going to return 10. And the number of square meters will be self.0. This is a tuple structure, so we're just accessing the first field, which is .0. Next, we need to implement the trait for the other two structures, so I'm going to do that now. Now that we've implemented the material trait for each structure, we can create some materials and then add up the costs. Let's hop back down to the main function. I'm going to create a carpet. And we need 20 square meters. We'll have some tile with 10 square meters. And we'll have wood. And for wood, we'll do 30 square meters. We then need to put all these materials into a vector. And the vector has to be annotated in order to use dynamic dispatch. So we'll use vec box din material to specify that we want to use the material trait instead of the concrete structure type. Last thing we need to do is calculate the total cost. So we'll create a total, use our total cost function, borrow the materials, and then just print out the cost. To run the program, we'll go to terminal at the top, new terminal. We're in activity 31, so do cargo run --bin A31. And the total cost for this listing of materials is $950. So what we did for this activity was we created a material trait, and the trait has the cost per square meters, which just returns how much it costs for that particular material, the number of square meters for that material, and we have a total cost function with a default implementation by using curly braces. So we didn't need to implement this for anything. We then implemented the trait for each material. We have a total cost function that takes a vector that contains boxes that contains din material. We then mapped each box and we got the material and did the total cost function, which is defined on the material trait. We then summed it all up to get the total cost. In our main function, we boxed up some materials, placed them all into a vector, and then borrowed that vector with the total cost function. We then have the total cost and we printed it out to the user. This concludes the activity on trait objects. I'll see you in the next presentation.